Imagine this. The power's out. And I don't mean for a few hours. I mean permanently. While everyone else is staring up at those dead power lines, just praying for a miracle, you're looking down, because you know a secret. A secret physics has been trying to tell us for, 200 years now? Today, we're not just going to survive. We are going to hack the planet.
All right, let's talk about what happens in a real long-term survival scenario. What's the first thing to go? Batteries. A single AA battery, that becomes currency. A working car battery, man, that's like gold. But here's the thing about relying on scavenged batteries. It's a dead end. They all eventually die. But you know what doesn't die? Chemistry. Chemistry is eternal.
I want you to really imagine total darkness. And I'm not talking about a regular power outage, where the streetlights are off. I'm talking about a suffocating, heavy, oppressive darkness. The kind you only get when the entire grid has collapsed for good.
In that world, your phone is nothing more than a brick. Your flashlight? Dead. The radio? Just static. You are completely cut off from the rest of the world, from all of human history. And that silence, that absolute isolation, the psychological weight of it breaks most people in about 3 days. They panic. They just freeze.
But not you, right? In the middle of all that chaos, you're smiling. Why? Because while they're all looking up at those useless, dead wires, you're looking down, right at the solution. Because you know a secret. The ground beneath your boots, it isn't just dirt. It's a battery. Think about that. A massive, literally endless reservoir of electrons just waiting to be tapped. And that's what we're going to do. We're going to build an Earth battery, and we're going to do it with nothing but garbage and some basic chemistry to generate free, infinite electricity. So forget about generators, forget about solar panels, forget trying to find fuel. The real secret here is something called a galvanic cell. And the crazy part, it's the exact same basic principle that's powering the battery in the phone you might be holding right now. Okay, so let's get into the basic physics of this. Don't worry, it's simple. At its heart, electricity is just the movement of these tiny little particles called electrons. That's it. The whole trick, the entire secret to power, is just getting them to move from one place to another. And it's surprisingly simple how you do that. Think of it like this. Some metals are, they're greedy. They want to hold on to their electrons really tightly. But other metals are generous. They give them away super easily. So what happens when you put two different metals like this into a conductive medium, something we call an electrolyte? Well, the electrons naturally flow from the generous metal, that's our anode, over to the greedy one, the cathode. And that flow, that, my friend, is electricity.
And that brings us right back to the mud under our feet. See, wet soil is naturally full of water, salts, all kinds of minerals, and that makes it a perfect electrolyte. It's like this giant, untapped ocean of potential energy, right there. You just need the keys to unlock it. So, what are the keys? Well, you need 2 different metals. Specifically, you're going to need copper and zinc. Now, I know what you're thinking. I don't have like bars of zinc just lying around. But here's the thing. Oh, yes, you do. You just don't know it yet. Think about it. Copper is literally everywhere. You can strip it from old wires in an abandoned house, a broken lamp, even a car. That's your greedy metal, your cathode. Now, for the generous one, the anode, you need zinc. And what's the absolute best source of zinc in a collapse? Galvanized nails. That dull gray coating on them, that is your fuel. All right, you ready? Let's build this thing. Step 1, find some wet ground. This is crucial. Dry dirt is an insulator. It won't work. But wet dirt is a conductor. And hey, if you have to, even urine works. Actually, the salt in it can boost the conductivity by like 300%. So once you've got your spot, bury a coil of that copper wire deep in the mud. That's your positive terminal. Now, about 6 inches away, bury a handful of those galvanized nails. Super important, make sure they don't touch the copper. That's your negative terminal. The final step? Connect a wire from the copper to the nails, and just like that, you've completed the circuit. The second you do that, a chemical reaction kicks off, and my friend, you've just created voltage. Okay, so here's the reality check. One single cell like this, it produces maybe half a volt to 0.9 volts. That's not enough to charge a phone. Heck, it's barely enough to tickle a frog. And this right here is where most people quit. They'll hook up a meter, see that tiny number, and say, see, it doesn't work. But you're not most people. You're an engineer now, and you know the secret of series versus parallel circuits. So you've built your first cell, you put a meter on it, and yep, just under a volt. It's not much to work with, I get it. And like I said, this is where most people would just give up. But you gotta understand, this isn't the end result. This is just your first building block. So the big question is, how do we get to usable power? Well, the secret isn't to build a bigger battery. No, it's to build more of them. You don't just dig one hole, you dig 10. You create a whole array of these small cells. And then you wire them all up in a series chain. It's simple, positive to negative, all the way down the line. And when you do that, the voltage just adds up. So 10 of these little cells, that's going to give you somewhere between 5 and 9 volts. And that is enough to light up an LED. That is enough to power a small radio.
And you have to think about the massive psychological advantage this gives you. I mean, imagine your neighbors sitting there in absolute pitch blackness, terrified of every little sound in the shadows. But you have light. Even a single tiny LED bulb completely changes the psychology of survival. It keeps predators away, both the four-legged and two-legged kind. It lets you work, read a book, repair your gear. Light is morale.
But wait, there's one more trick, a little hack to make this whole thing way more efficient. See, your Earth battery produces a nice, steady voltage, but the current, the amperage, is pretty weak. The solution is this clever little circuit called a Joule Thief, and you can scavenge one from any of those cheap solar garden lights you see everywhere. You know, the broken ones. This little thing takes that weak, steady power and converts it into these high-energy pulses, stepping up the voltage so it can actually run a light properly. It's the missing link between your mud battery and a bright, working light. Okay, this is great if you're hunkered down in one spot, but what if you're on the move? What if you can't just go around digging holes everywhere? Well, that's when we take this to the next level. We build a portable version. Get this, take a regular old ice cube tray, fill up each one of those little slots with wet mud or even sand. Then, in each slot, you stick a piece of copper wire and one of your zinc nails. Wire them all up in series, just like before, and boom, you've got a 12-cell battery that fits in the palm of your hand. It'll put out around 10 volts, it weighs almost nothing, and the best part, to recharge it, you just add more water. This thing is the ultimate MacGyver power source. You know, what's so incredibly powerful about this whole concept is that it's completely decentralized. It's uncontrollable. You can't put a power meter on the dirt. Once you really grasp this basic physics, your whole perspective shifts. You realize the entire world, the entire planet is your power grid. You stop seeing the ground as just dead matter, and you start seeing it for what it really is, pure, raw energy. So, you've mastered energy. You've learned to pull power right out of the ground. But mastering energy? Well, that's only the beginning. Because there's always a catch, right? This energy is infinite, sure, but it's a slow trickle. And the zinc on your nails, your fuel, it'll eventually corrode and need to be replaced. This isn't some magic wand. It's more like a relationship with the earth. But look, in a world where the lights have gone out forever, a dim light that you control is infinitely better than no light at all. So let's lock this in. This is your new power protocol. 1. Scavenge copper wire and galvanized nails. 2. Keep your soil wet. 3. Wire your cells in series to boost that voltage. 4. Salvage a Joule Thief circuit to make it all usable. And 5. The most important step of all, never, ever rely on the grid again. From now on, you are the grid. You've conquered darkness. You've mastered energy. But in this new world, there's another threat. One that's even more deadly than a power outage. Because in a world without modern medicine, without antibiotics, a simple scratch can be a death sentence. The next threat we have to face is infection.